Good day everyone. You already learnt integration, many methods. All that we can put under the head indefinite integrals, because in all the models, in all the sums, we will add one C, which is called the constant of integration. That C can take any value. So they are all called indefinite integrals. Today you are going to learn definite integrals. Let me tell you the difference between the indefinite and the definite, and then we will go with the sums. If you consider some integrand f of x, that is integral f of x dx. If you integrate, let us say you get capital F of x, you will add one C in indefinite integrals, right? Now, in definite integrals, in the sum itself, you will be given two limits, that is, it will be given like this. You have to read it as integral a to b f of x dx. A is called the lower limit and b is called the upper limit. You will be getting that same f of x, but here there is no c. You will put a bracket, write the lower limit here, write the upper limit here. That means in the f of x function, in the place of x, first substitute the upper limit, then minus, then substitute the lower limit a. So you will be getting f of b minus f of a, and that will be a finite answer. So it is called definite integrals. Okay. Let me tell you the geometrical meaning of both so that it will be clear to you. Indefinite integrals, actually the geometrical interpretation is you will be getting a family of curves, that is indefinite integral. In definite integrals, you will be getting the area under the curve y is equal to f of x, x-axis, and the two ordinates x is equal to a and x is equal to b. This is the geometrical interpretation. Okay. So now we will move on to definite integral sums. There we can categorize it into two types I can call. The first one is any method of integration, whatever we used in indefinite integrals, we will be substituting the limits. That is the upper limit and lower limit. Then the second one is there are some properties of definite integrals. Using that we will be integrating. So today let us see the first type. Okay. Let us take a simple sum. I is equal to integral 1 to 3 2x minus 1 dx. This is a linear algebraic function. Actually, you can integrate it in two ways. That is, there are two terms, 2x and that one. You can integrate them separately and you can substitute the limits. That is one way of doing. Another way is you can consider the 2x minus 1 within bracket as one whole term, that is power 1, so that you can integrate it like 2x minus 1 the whole square by 2. Then of course the coefficient of x also we will put in the denominator. I am going to follow the second method because that will be easier for many sums. Here you can do by any method, the answer will be same. So now the 2x minus 1 power 1. So when I integrate I get 2x minus 1 the whole square by 2. Then another 2, that is that coefficient of x. Now I will put a bracket, the lower limit and the upper limit, right? Always take the constants outside so that it will be easy for you. The calculations will be easier. So now let me take that 1 by 4 out. So I am getting 2x minus 1 the whole square 1 to 3. So first I have to substitute the upper limit in the place of x. So 2 into 3, 6. 6 minus 1, 5. 5 squared will be 25. Okay. Minus lower limit. 2 into 1, 2. 2 minus 1, 1. 1 squared will be 1. So I will be getting 1 by 4 into 24, which is equal to 6. Is it clear? So just integrate the normal way. Substitute the upper limit in place of x minus substitute the lower limit in place of x. That's all. Okay. Let us move on to the second sum now. I is equal to integral 0 to pi by 2 cos squared x dx. Hope you remember how to integrate cos squared x that you have learned in indefinite integrals. Any angle like square, cube, if you have in trigonometric function, you will express it as multiple angle, right? That is, I can write this cos squared x as 1 plus cos 2x by 2, then write the dx. All the trigonometry formulae you should remember well. This 2 in the denominator can be taken out as 1 by 2 and you will get here 1 plus cos 2x dx. Now both are easily integrable, isn't it? So put the half out. For 1, when you integrate, you get an x. For cos 2x, you will get sin 2x by 2. Okay? So you will get sin 2x by 2. That is the coefficient. Then write the limits 0 to pi by 2. Okay? Now, two terms. So I will substitute it separately. Here also, if you want, you can substitute the upper limit for both the terms, then minus the lower limit for both the terms. But I am going to take term by term so that the mistakes you commit will be less, definitely. The chances will be less, I can say. So now half. I will take an x here, 0 to pi by 2. Then 1 by 2, this 2 is there, so 1 by 4, sin 2x, then 0 to pi by 2. So here half pi by 2 minus 0, right? Plus 1 by 4, sin 2 into pi by 2 will be sin pi. You know sin pi is 0. Then lower limit, sin 0 is also 0. So both the upper limit is 0 and the lower limit is 0 when you substitute. So this term actually vanishes. So here half into pi by 2, that will be equal to pi by 4. So in the method of integration, remember I am again telling you, you will get any method, completing the square method, by parts, then partial fraction, whatever method you get, you have to normally integrate and then you have to substitute the upper limit, then minus the lower limit. Okay, remember this. Third sum, I is equal to integral 0 to pi by 2 cos x by 1 plus cos x plus sin x dx. You know the half angle formula for cos x, for 1 plus cos x and also for sin x. So let us use it and see whether we are able to simplify the integrand. Okay. So now I am going to write the cos x as cos squared x by 2 minus sin squared x by 2. That is, cos x is nothing but cos 2 into x by 2. Okay. So cos 2x formula I am applying. For this 1 plus cos x, you will get 2 cos squared x by 2 plus sin x will be 2 sin x by 2 cos x by 2 then dx, right? Now the numerator is like a squared minus b squared. So write it as a plus b into a minus b. Use that formula. Okay. So you get like this. Coming to the denominator, you can take 2 cos x by 2 common. So take 2 cos x by 2 common. You will be getting cos x by 2 plus sin x by 2 then dx. These two terms will get cancelled, right? Now you can take this 1 by 2 out. So you will get cos x by 2 by cos x by 2 minus sin x by 2 by cos x by 2. Okay. So now I will write the 1 by 2 out, 0 to pi by 2. First cos x by 2 will cut each other, you will get 1. Then next is sin x by 2 by cos x by 2, which is tan x by 2 then dx. Both the terms are easily integrable. Let us integrate. So half, okay. For 1 it will be x. For tan x by 2 it is log mod secant x by 2 by 1 by 2. Then write the limit 0 here and pi by 2 here. Okay. So now again you are having two terms. So let us separate them. So half x within 0 to pi by 2. This half and that half will get cut. So you will get minus log mod secant x by 2 within the limit 0 to pi by 2. Okay. So for the first term, pi by 2, the lower limit is 0. So you will be getting half into pi by 2. That will be the first term. Coming to the second term, okay, that is minus log secant, okay, x by 2. So pi by 2 by 2, that will be pi by 4. So secant pi by 4, then minus lower limit, it is 0. So 0 by 2 is 0. So log secant 0. Log secant 0. Okay. So now this is now pi by 4 minus secant pi by 4 is root 2. So you will get minus log root 2. Secant 0 is 1 and log 1 is 0. So that will vanish. So pi by 4 minus log root 2. You can leave it like that. Or the log root 2 you can write it as, no, you can write log 2 power half, isn't it? That half can come here. So you can write it as pi by 4 minus half log 2. You can write like this or you can write like that, because sometimes, no, you will be worried if you don't get the book back answer. That is why I am telling you can write like this also. So do you understand this sum? Here the important thing is this formula application, the trigonometric formula you should remember and use. Then of course things will become easier for you. Okay. Fourth one, I is equal to integral 0 to 1 x log 1 plus 2x dx. You can see in the integrand two different functions. No, x is the algebraic function and log 1 plus 2x is a logarithmic function. So you know you have to use integration by parts. Using Eilert rule, log, that is that L comes before a, that is algebraic function. So we will take the u function as log 1 plus 2x and that x dx, that will become the dv function. Okay. So now you differentiate this. So du will be 1 by 1 plus 2x into 2, because 2x if you differentiate, that is 2, then dx. Here if you integrate, you will get v is equal to x squared by 2. Let us write the formula. Integral u dv is equal to uv minus integral v du. This will become I and uv. So you will get x squared by 2 log 1 plus 2x. Here the important thing you have to remember is the limit in the given sum will be applicable for this part as well as this part, because this is the given sum. So for uv also you have to put a bracket and you should write 0 to 1. This is very important. Then minus integral 0 to 1 v, that is x squared by 2, then du, that will be 2 by 1 plus 2x dx. 2 and 2 will go. Okay. So first you are applying by parts. In that the limits will apply for both the terms uv as well as for v du. Remember that. So now you are getting x squared by 2 log 1 plus 2x within that limit 0 to 1 minus, I will put this as I1 because I want to work it out. I will call this as step 1, right? So now I1, that will be integral x squared by 2x plus 1 dx. The limit is 0 to 1. Now if you look at the numerator and the denominator, you can find it out. The degree of the numerator is greater than that of the denominator. So what you should remember now? Divide, because it becomes an improper rational function. So you have to divide now and express it as quotient plus remainder by divisor. So now let me do the division here and we can do it. So x squared, I have to divide it by 2x plus 1. Okay. Always first term divided by first term. You find it out. So x squared by 2x, that will give you x by 2. So with that multiply the two terms. X by 2 into 2x will give you x squared plus x by 2 into 1 will give you x by 2. Right. Now change the sign, minus, minus, this will get cut. You will get minus x by 2. Now you cannot stop it because the degree of the remainder is 1 and this is also 1. So I have to go one more step. So now again, this by that you have to just see minus x by 2 divide by 2x. That is, you can reciprocate minus x by 2 into 1 by 2x. X will go, you will get minus 1 by 4. Is it clear? So write the minus 1 by 4 here. Now this into this will give you minus x by 2. Minus 1 by 4 into plus 1 will give you minus 1 by 4. Change the sign. Cut this. So now you get 1 by 4. Now the remainder is 1 degree less than that of the divisor. So you can stop that. Right? You have to remember all these concepts which already you have learned in the indefinite integrals. So coming here, I can write it as integral 0 to 1. Quotient. What is the quotient? X by 2 minus 1 by 4 plus remainder, that is 1 by 4 by divisor. Then write that dx. Okay? So now, once you write it, now we can just properly write this and we can start the integration. I think now that you know this, I am just... So let us proceed now. So now the I1 is going to be now integral 0 to 1 x by 2 minus 1 by 4. This 4 can come to the denominator. So you can write 1 by 4 into 2x plus 1 then dx. Okay. So now if I integrate, this is for x it will be x squared by 2. There is already 1 by 2. So I will be getting x squared by 4. Here I will be getting 1 by 4 then x, because just x will come there. Here also 1 by 4 then log mod 2x plus 1 by 2. Do you follow? Then put a bracket, write the limits 0 to 1. Now let us go term by term. So for the first term, it will be 1 by 4, then x squared 0 to 1. Second term, minus 1 by 4, x 0 to 1. Third one, 1 by 8, log mod 2x plus 1, 0 to 1. Okay? So that there won't be any confusion and it will be very clear. So now, 1 by 4, this is 1 minus 0, so you will get 1. Minus 1 by 4, here also it is 1 minus 0, so you will get 1. Plus 1 by 8. If you substitute the upper limit, 2 1s are 2, 2 plus 1, 3. So you will get here log 3 minus. If you substitute the lower limit 0, 2 into 0 is 0, 0 plus 1 is 1, so you will get log 1. Of course, you know log 1 is equal to 0. So this 1 by 4 and this 1 by 4 will get cut. You will get this is 1 by 8 log 3. So this is the I1 now. Mark it as 2. Now, in the first part, this part we have not yet evaluated. We have not applied the limits, remember that. So now we have to substitute the 2 in 1 and we have to evaluate it. So now we will be getting I is equal to. Now see here, these two terms, they are actually as a product form. So here I cannot substitute the limits separately. Only when there is a plus minus I can separate the terms. So this is one term actually. So now when I substitute 1, I will be getting here 1 by 2. Okay. Then log 1 plus 2, that is 3. So I will get log 3. If I substitute 0, it becomes 0. 0 into anything will be 0. So the first part, after you apply the limits, becomes 1 by 2 log 3. Then minus I1. Minus I1 is 1 by 8 log 3. Now log 3 is common. So let us take log 3. You will be getting 1 by 2 minus 1 by 8. 8 is the LCM. Okay. If you take 8, you will be getting 4 minus 1. So you will be getting 3 by 8. So 3 by 8 log 3. Is it clear? So in integration by parts is the method if you use here. Remember to put the limits for this UV also, because this you may not forget, but this part you have to remember. Hope this is clear to you. Now in the fifth sum, we are going to see a bit different model, okay? In the four sums you have seen, we have integrated the integrand part and we have substituted the upper limit minus lower limit. So what is the difference in these two sums? Let us see. Now here you can see x in the numerator and x squared plus 1 in the denominator. So you know here the method you have to use is substitution, right? Even in that it will come after one step. So when you use substitution as a method in definite integrals, you should remember, usually whenever you substitute, you will immediately differentiate, right? Because you want that dx and the related term as what? Here one more step, that is the limits given are for x. Because we are substituting some other variable, we have to change the limits. That is the main thing you are going to learn in these two sums. Okay? So now here, you can either substitute x squared or you can substitute x squared plus 1, that doesn't matter. I am substituting x squared plus 1 is equal to t. Next step what? Differentiation. So I will be getting 2x dx is equal to dt, or x dx, what I have here, no, that will become 1 by 2 dt. These two steps you know already. Now one more step is changing limits. As I told you, the limits given are for the variable x only. So now when x is 2, that is the lower limit, what will be t? 2 squared plus 1, so t will become 5. When x is 4, t will become 4 squared, that is 16 plus 1, 17. So this is the important step whenever you use substitution in definite integrals, never forget it. So now I will be equal to, now the change limits 5 and 17. X dx is half dt. Write the half here, dt by t, right? Now you know dt by t means you will be getting log mod t, then 5 and 17. So half log mod 17 minus log mod 5. So it is like log a minus log b. I can write it as log a by b. So I will be getting log 17 by 5. That's all. Okay. So have you understood what difference now? Changing the limits. Now let us come to this. You have tan cube x in the numerator. You are having 1 plus cos 2x in the denominator. You know 1 plus cos 2x is nothing but 2 cos squared x. If we use that, the cos squared x will go to the numerator as secant squared x, and definitely the sum will become a sum based on substitution, right? So now the first step is 0 to pi by 4 tan cube x by 2 cos squared x. Okay? Take the 1 by 2 out. 0 to pi by 4 tan cube x. The cos squared x you can write here as secant squared x dx. Now you know you can substitute tan x as t, so that the secant squared x dx will become dt, right? So now let us substitute. Tan x is equal to t. So secant squared x dx will become dt. Change limits, don't forget, changing limits. X is equal to 0. So t is equal to tan 0, which is 0. Then upper limit, x is equal to pi by 4. T is equal to tan pi by 4, which is 1. Okay. So now the I will become, you have a half outside, the limits will be now 0 to 1. This will become now t cube. The next part, that will become dt, right? So very simple integration, half into t power 4 by 4, the limit is 0 to 1. Okay. So now take that 4 out. So 1 by 8. Then 1 power 4 is 1, then 0. So the answer is 1 by 8. So all the sums which I explained today, hope that will be clear to you. So today we have seen the first type I told you, that is normally integrating by any method and then substituting upper limit minus lower limit. In that, the one thing you have to remember is when the sum is based on substitution method, after you substitute, after you differentiate, change the limits. Okay? So that's the thing. So if this is clear, in the next video, we can go for the properties of definite integrals. Thanks for watching the video. Share it with your friends and classmates. Okay?